Okay, so we're going to solve by completing the square. So first move that thing over. So 2x squared plus 4x equals -1. We subtracted 1, divide everything by 2. So we get x squared plus 2x plus blank equals -1/2. Sorry, -1/2 plus blank. So half of 2 squared is 1, so add 1 to both sides. That should be a perfect square. X plus and plus, square root of 1 is 1. -1/2 plus 1 is 1/2. Take the square root of both sides. We're going to solve this thing. Get x plus 1 equals plus square root of 1/2, which is square root of 1. Typically, we like to simplify the radical in the denominator, so we might multiply by square root of 2 over square root of 2, and then subtract 1, so x equals -1 plus or minus, I guess that would be square root of 2 in the numerator divided by 2 in the denominator. And using the quadratic formula, so x equals the opposite of b would be 4 over 2 times 2 plus or minus square root of b squared, which is 16 times 4 all over 4. So we get -1. Well, that looks a lot like the left-hand side. This is the same problem done a different way, by the way. This is square root of 8 over 4. Square root of 8 can simplify if you do prime factorization of 8. 2 and 4, 2 and 2. You get a pair of 2's with a 2 left over, so this is -1 plus or minus 2 root 2 all over 4, and that cancels. And so you get the same answer of x equals -1 plus or minus square root of 2 over 2. Good so far. So this one we're going to solve by factoring and see if we get the same answer doing it also by complete or quadratic formula here. So n, and then factors of 35, I'm thinking 7 and 5, and that looks good for 12, so maybe minus and minus. I think that works, so n equals 7 and n equals 5. Over here, quadratic formula, so n equals opposite of 12 over 2a. Square root of b squared is 144 minus 4 times 1 times 35. So we get 6 plus or minus 144 minus 140 is just square root of 4 over 2. So that's 6 plus or minus 2 over 2, which is 1. So it's really two different answers. 6 plus 1, which is 7, and 6 minus 1, which is 5. So you certainly could guess and check this. I'm just going to do AC because a number of you like that. So AC would be 6. Factors of 6 would be 1 and 6 or 2 and 3. Everything's positive. They add up to 5, so it's got to be 2 and 3. So let's split up that middle term. So it's going to be 3x squared plus 2x plus 3x plus 2. Group the first two terms, last two terms. You get x times 3x plus 2. Sorry, it's a little sloppy there. Plus 1 times 3x plus 2. Notice, like I took the 1 out just because it's going to make our next step easier when we regroup it. So it should be 3x plus 2 times x plus 1. So clearly one answer is x equals -1. This one you might actually have to set it equal to 0 to find it. So 3x equals -2, so x equals -2/3. Then solve using the quadratic formula. That would be x equals the opposite of b, so opposite of 5 over 2 times, which is 3. Square root of 25 minus 4 times 3 times 2. Oops, that's a 2. So that's 6 times 4 is 24. So this is -5, 6 plus or minus square root of 1. two different answers, right? That's going to be negative 5 plus 1, which is 4, 6, negative, I guess, which is negative 2/3. So we get the same two answers, x equals negative 2/3 and x equals negative 1. Okay, so let's just do discriminant b squared minus 4ac. So that would be b squared, and this one would be 4 minus 4 times 1 times negative 5, which is 4 plus 4 times 5, which is 20, which is 24, which is positive. When the discriminant is bigger than 0, there are two real solutions. In fact, if you want to say are they rational or irrational, technically that's not a perfect square, so I would say they are two irrational real solutions. Let's try this one. So opposite b squared would be, b squared is 16 minus 4 times 2 times 1. 16 minus 4 is 8. Oh, wait. Yeah, okay, that's right. 16 minus 4. If discriminant is less than 0, you have 0 real solutions. If discriminant is equal to 0, you have 1 real solution, just so you know the other cases there. So the vertex is always h and k. Any other point on the parabola is x and y. Shortcut way of doing this, you might see that you go over 1, up 1. That's where I would expect to be, but they went over 1, up 2. So I kind of know a equals 2, but if you don't see that, that's okay. And there's no graph paper here, so that makes that especially tough. So let's just plug in what we know. Y is 2, or negative 2, I guess. A is 4, minus h is so minus a negative 3, plus 3, plus negative 4. Okay. So solve that, so it's negative 1 squared, which is positive 1. So we get negative 2 equals a minus 4. Add 4, you get 2 equals a, which is what we expected. So our equation is y equals 2 times x minus negative 3, which is like plus 3, minus 4. So in this one, I'm going to start by writing out the points I know and love, 1, 1, 2, 4, because my a value is not 1 here, negative 1, 1, and negative 2, 4. All the y values get multiplied by negative 1/2, well, that's still 0. That's negative 1/2. That's negative 2, negative 1/2, negative 2. So to plot those points, 0, 0, 1, negative 1/2, 2, negative 2, negative 1, negative 1/2, and negative 2, negative 2. So my parabola looks something like that. Here I don't have an a value, so I don't need to write out the order pairs. That's going to go to the left 2 units and down 1 unit. So I'll take my points I know and love. 0, 0 goes to the left 2 and down 1. That's my new vertex. If you know your pattern, normally it goes over 1, up 1. So over 1, up 1, because A is positive. Over 2, up 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. And you've got your graph. So this one, I'm probably going to use the h equals opposite b over 2a method here. So h equals the opposite of b, which would be opposite of 4 over 2 times a, which is negative 2 in this case. So we're going to plug that in for an x. So k equals negative 2 squared plus 4 times negative 2 plus 1. So it's going to be 4 minus 8, which is negative 4, plus 1 is negative 3. So I know my hk is at negative 2, negative 3. My A value is 1, so I know to go over 1, up 1, over 2, up 1, 2, 3, 4, over 2, up 1, 2, 3, 4, and I've got my parabola. Here, let's do the h equals opposite of b over 2a, so h equals the opposite of b, which is 8, over 2 times negative 2, so 8 over negative 4 is negative 2. That's about the same we got last time, so k is negative 2 times negative 2 squared minus 8 times negative 2 minus 6. So that's 4 times negative 2 is negative 8, plus 16 is positive 8, minus 6 is 2. So negative 2, 2 is my vertex. A is negative 2, so I'm going to go over 1, down 2, over 1, down 2, over 2, down 1, 2, 3, 4, 5, 6, 7, 8, over 2, down 8. Instead of over 2, down 4, it's a much skinnier parabola. All the y values were multiplied by negative 2 there. And you can graph it. Consider these some of the toughest ones on the test. So let's do complete squares. So 5 over 4 times 4x squared minus 12x. Factor out that leading coefficient of 4, so y minus 5 equals 4 times x squared minus 3x plus blank. And I'm going to add something over here as well. Okay, so half that middle number squared. Wow, this is a pretty intense problem. So half of 3 halves squared would be 9 fourths. So to add 9 fourths, the other side, because remember this is being multiplied by 4. So let's do that. 9 fourths times 4 is actually, the 4's cancel, is just 9. So I'm going to add 9 to the other side to be fair. So I get y plus 4 equals 4 times x minus the square root of 9 fourths is 3 halves. Last step, subtract 4, y equals 4 times x minus 3 halves squared minus 4. Told you this is getting the tough stuff. Okay, similar step here, subtract 1, so constant y minus 1 equals negative 2x squared plus 4x. Factor out the a value there, negative 2 times x squared, it's going to be minus now, I guess 2x plus blank, and plus blank. So what do we add? Half of negative 2 is negative 1, negative 1 squared is 1. Subtract 2 because that negative 2 is being multiplied, so you get y minus 3 equals negative 2x minus 1 squared. Okay, last step, 3 to both sides, y equals negative 2 times x minus 1 squared plus 3. And you got in vertex form. Solve by graphing on Inspire. Okay. So let's get this so you can see it. Okay, so let's graph. Hit the home key, go to graph. You might want to let's subtract 9 and add 4x to both sides. So we'll graph that. So it'll be 2x squared. Oops. 2x squared minus 9 plus 4x. Looks like that. And you're going to use the trace command, menu 5.1. 1.35, so x equals 1.35. That's one of the x values for the 0. Oops. And let's get this other one. So if you're over here, cursor to the left, x equals what? Negative 3.35. X equals negative 3.35 is the other solution. So there are two solutions there. Set this one equals 0. Oh, it's already set equal to 0. This should be quick. So x squared minus 2x minus 4. Trace that thing. So menu 5.1. 3.24, so x equals 3.24. Whoops, keep doing that. Gotta go back to the calculator, controlling the PDF here for a second. So if on the calculator screen, if I cursor left, negative 1.26, x equals 24 actually. Okay. And do some imaginary numbers. So this one, pull the I out first. So this is I times root 24. If you do a prime factorization of 224, that's 2 and 12, 2 and 6, 2 and 3. So 2 comes out with 6 left over inside. So this would be 2I root 6. I like to subtract these. So add negative plus. Okay, so 9 minus 6 is 3, 7I plus 2I plus 9. FOIL this guy, so this would be 3 plus 2I minus 27I minus 18I squared. Now I squared is really negative 1, so that's like boom, boom, plus 18. So 3 plus 18 is 21. And this would be minus 25I. Here you're going to have to multiply by the conjugate. Conjugate of 6 minus I is 6 plus I. Denominator should simplify. 36 minus I squared, which is like boom, boom, plus 1, because that's a minus a negative 1. So that's 37. And that's not going to cancel, so you could go ahead and multiply it. So it'd be 30I plus 5I squared. 5I squared is 5 times negative 1, so negative 5 plus 30I in the numerator. You can write that as two separate numbers. Sometimes that's preferable. I don't think I'll take off if you don't. But A plus BI, so 30I over 37. And just a couple more problems, I guess. Well, a few more. Okay, solve each equation. So subtract 9, so you get x squared equals negative 9. Take square root of both sides. Don't forget plus or minus. So x equals plus or minus square root of negative 9, which is 3I. Let's subtract 10. Actually, you know what? Let's move these over to this side because that'll make the x squared positive, which I like a lot better. X squared minus 4x plus 10. So I don't think that factors. 5 and 2 don't add up to 6. 10 and 1 don't add to 6. So I'm going to do quadratic formula, I guess. So opposite b would be 4 over 2 times 1 plus or minus. B squared is 16 minus 4 times 10. 16 minus 40 is negative 24. So this ends up being 2 plus or minus I root 24 over 2. I think we just did a minute ago. We did that. That was 2 root 6. So this is 2 plus or minus 2 root 6, 2I root 6 over 2, so that the 2's cancel. So you end up getting 2 plus or minus I root 6. If you're factoring, this one just looks like it has a GCF, 6x, well, at least that's what it looks like at first, times x squared minus 4. Oh, more factoring to be done. So 6x, hopefully you see that that's difference of squares. So x and x, 2 and 2, one of them's plus, one of them's minus. And you have to solve this factor. Ooh, this one looks tough. Let's make it easy. Let's factor out the GCF of 2 first. So x squared minus 14x. I don't know if it's easy, but it's easier. Plus 49. Well, I like that. This would be x and x. Got to be 7 at 7. Minus and minus, and you got it. Use words to describe the transformation. So this one is reflect over the x-axis. This goes to the right 2, and this goes up 6. This one is a vertical shrink, because it's smaller than 1. Stretch if it's bigger. Goes to the left 4, so left 4. And that's it.